Hello everybody, it's day 32 of our astronomy unit. I'm Andy Pilc, and in today's lesson we continued talking about asterisms and constellations. In this video I'm going to be using a simulation to take a look at how our ability to see constellations changes, either depending on where we are, depending on the conditions of where we're trying to view the stars, the time of year, and how they change over the course of the night. So in order to kind of investigate these things and show and talk about them, I'm going to be using the In the Sky simulator again. So if you watched the video, hopefully you found this website, inthesky.org. We're going to click on the planetarium, and that is going to take us to this interactive simulator. I have my location set to New York City, and I am going to zoom out my field of view, increase my field of view to 180 degrees. Let's change some of these settings to make our sky a little bit easier to see. So I'm going to turn off deep sky. I'm going to show the stars. I will show and label the planets. And I'm going to turn the constellation names off for now. So one of the things that's going to change over the course of the night is the position of the stars and the planets in the sky. And we can see that if we click on the change time drop down here, and I'm going to animate it. So we're going to see all of the celestial objects that we can see. They're going to rise in the east, just like the sun would. And across the celestial sphere, we're going to see everything setting in the west. Oops, remember this is apparent motion. Oopsie, oopsie, oopsie. Meaning things are appearing. Why can I not move this? They're appearing to move. This is what I wanted to get. Sorry, they're setting in the west. So they're appearing to move because of the Earth's rotation. These things, they are moving incredibly fast, but relative to us, they're not moving very much. The reason that we're seeing these things move is because of Earth's rotation. You're also going to see as the sun, as the planets move across the sky too, they're going to be in line. We call that the ecliptic. There's our ecliptic there with all of the planets in line. And all of these constellations right now are circumpolar, meaning they are all circling the star Polaris, which is most aligned with our celestial North Pole. So if Earth's North Pole is here, Polaris is aligned with it. So as the Earth rotates, the North Pole is always going to be pointing towards Polaris. So we can find it in this simulator by figuring out the point where all of the stars are rotating around. And here we see Ursa Major, so that can also give me a hint as to where Polaris is. So here's the Big Dipper. I know that these two stars are going to point at Polaris. And here's the Little Dipper. The star at the very end of the handle is going to be our Polaris. So over the course of the night, all of the stars, all of the celestial objects, they're going to be rotating 15 degrees per hour around Polaris. Let's pause it. If we were to change the date and not just the time, if I'm just changing the day, we're going to see the constellations stay relatively in the same location. But as I go forward and backwards in time, we're going to see the planets moving across the sky throughout the night, across the ecliptic. That's why when we're making asterisms and constellations, we can include planets with them. Because although the stars and the constellations stay relatively constant over the backdrop, the stars and the planets, they're going to move much more relative to that backdrop. Another thing that's going to affect our ability to see the stars, and if you're here in New York City with me, you will know all about this. This is going to be the light pollution. So let's turn these stick figures off just to kind of get a look at the sky. So if we were in an area that doesn't have a lot of light pollution, think of like the countryside or the Poconos, we would be able to see a whole lot of stars. But as there's more light kind of making our area brighter, it's going to be harder to see those stars in the sky. So this limiting magnitude, right now we see showing stars down to a magnitude of 5.9. If I add light pollution, then I'm only going to see stars up to a magnitude of 4.7, I'll see less stars, and then if it's very, very bright in the sky, I'll see even less stars. So that's the reason why we can't see any stars here in New York City, because it's the city that never sleeps. We have all those lights on. Another thing that could also change your ability to see constellations would be the time of year. So let's turn those stick figures and names on. So if I were to look up in the sky, there are some constellations that are always going to be there, just like Ursa Major and Polaris. The Earth's rotation will never allow, and even the revolution will never allow us to not see some constellations. So we changed the time of night before, and we watched as the stars, planets, and constellations all moved circumpolar. But if I were to change the month, so if I were to go from July to August to September to October, we're going to see the constellations that are visible in the sky are going to be different. I think there's a way. Let's make sure that we have north up. So again, we'll go to October, November, and you'll see how the horizon is going to start to block what's visible, right? December, January, February, and we won't be able to see all of the constellations in the sky. We'll be talking more about that later on this week. But if I were in the southern hemisphere, so maybe I'm going to change my location to maybe Ushuaia, which is down in Tierra del Fuego, so one of the most southern points of South America. I'm going to see different constellations in the sky because I kind of have access to a different part of the universe being on the underside of the Earth relative to us. So if I were to change the time here and play the animation, these stars aren't necessarily circumpolar because on the southern hemisphere we can't see the North Pole. So the southern hemisphere's equivalent of the North Pole is a star called Sigma Octantis. And if we wanted to find this, we would find the constellation Octans, which is over here. And sorry for my navigation here. Let's pause the animation real quick. Let's turn deep space off and some of these other distractions, but I do need Octantis to be labeled, and there it is. So now I'm going to zoom in a little bit. And as I zoom in, I should be able to see more of these stars labeled. Oh, let's actually label the stars. And here is the equivalent of the North Star in the southern hemisphere, Cygnus Octantis. So all of the stars in the southern hemisphere are going to appear to rotate 15 degrees per hour around this star, which is in the Octans constellation, or that region of the sky, Octans. Let's go back to New York and take a look at anything else. Whoopsie daisy. So you can use this in the sky simulation to create your plan for stargazing in New York for July or August. So some of the things that you can do is you can change the month. So maybe I want to go stargazing on my birthday. And since I can't stay up too late, maybe I'm going to go outside at about 20 or about 8 p.m. or it's probably pretty late. I might have to go out a little bit later, maybe about 10 o'clock p.m. Let's go back there. So now I can scan the sky and I can see what constellations I would be able to find and what stars I would be able to find. If we wanted to, we can maybe get a little bit more realistic here in New York City. And then other things you might want to consider is like the location where you're going to see stars. You want to make sure that you're getting as far away from the lights as you can. And you also want to make sure that you have a place where you can see a good portion of the sky. If you have like a little courtyard or something outside of your building, it might not be the necessarily best place because you might have a building blocking some of your view. So maybe you want to go near water or anywhere else that's secluded where you can do some stargazing. That's it for the independent work. Let's just go over some check for understanding questions. I like these. These are pretty straightforward and easy, so let's take a look at these two. It says base your answers on the flowchart below and your knowledge of Earth science. Flowchart shows the evolution of stars. I actually don't think that that is a correct heading because it's not the evolution of stars. That would be like the early, intermediate, and late stages of the star. But let's see. On the star chart in your answer booklet, place a red P over the dot that represents Polaris. So we know that constellations are circumpolar, and all of these constellations will be going around Polaris. Also, we know that it is at the very end of the constellation, or the asterism Little Dipper. So there's Polaris right there. And the stars are going to rotate around Polaris counterclockwise 15 degrees per hour. So if I wanted to make sure that these lines were 15 degrees apart, I can count them, and I would get 24 representing 15 degrees per hour, or the 24 hours in a day. And it's looking to find where Merak would have been 5 hours after this picture was taken. So we're just going to keep Merak the same distance away from Polaris, and we're going to move it 15 degrees every hour. So that's 1, 2, 3, 4, 5. And we want to make sure that we do what the question asks. So we're going to put an X right there. Okay, that's it for today. Make sure that you go ahead and answer the wrap-up questions, and I'll see you for the next video as we continue talking about stars and constellations. Have a nice day.